Yeah, sorry if you were expecting Martin to be here today. I'm here in his stead. He's recovering from a very long trip. So, first question, how many of you were in Alonso's talk just now? Just a couple? Okay, good. He's doing good advertising work for us. And another question, show of hands, who has heard of Solara before? Quite a few people, okay. Well, hopefully it's not going to be too boring of a presentation for you guys either. So I'm going to be talking about specifically adapting Solara for big applications. And you want to build web apps with considerable scale in pure Python. So yeah, taking stuff beyond prototypes and dashboards. And what do I mean when I say beyond prototypes and dashboards? Well, we can look at this application here, which is built by the guys over at Planito Energy. And they've built this application purely in Solara. And you can see it's got some map view in it that you can select an area. You then get some simulation stuff on that area. They're trying to give you the best options to build a district heating and cooling network. So they find the nodes where you need heating, where you need cooling. You can give them the position that you would have, for example, a heat source, and they will simulate what the best network for that would be. And displaying it and everything in Solara. In addition to that, this app also handles everything that you would expect a proper web app to handle, so user authentication, user management for admin users, organizations, different projects for organizations, and that the right users have access to the right projects. So it's quite complicated. And that's what I hope I can convince you could build with Solara. There was already a short introduction of me. My name is Rotko. I'm a software engineer, as was said, at Widgety, where I work with the two co-founders of the company. And mostly I work on Solara. I contribute to some open source stuff on the side of the work, for example, IPy Leaflet, I've done some work on. And I also work on a new project of ours called PyCafe, which should let you run these UI apps without needing for hosting in the browser. And as was said before I became a software engineer, I was a physicist, I studied at the University of Groningen, and a web developer. So I work with Martin and Mario, the co-founders of the company. Martin's a former astronomer. He has experience with big data. He's one of the core devs around Vex. And he's created Solara, he's created IPy React, Reacton, and many of the projects that we're building Solara on top of. Mario is the other fundamental foundation piece there. He's a software dev, data engineer, and he's built IPyFutify and IPyFu, which are something that, again, Solara relies a lot on. So, what's the problem we're trying to solve with Solara? Well, I already said the large apps do it purely in Python. And what I mean with large apps, we already saw something with a complex UI, complex interaction. You need to go back, you need to compute stuff and keep the front end still available. And hopefully what Python can bring to this is also complex data, because people like to use Python for data analysis. But how would we go about building something like Solara that lets you do large apps in pure Python? Well, you want to learn from those that have done it before. And who builds complex UIs, complex user interactions? Well, that means you need to learn from JavaScript. And their ecosystem is huge, and they've been doing this for years. And in particular, we want to learn from React, because they're the big player in the game, long experience, proven technology, people are willing to rely on it. We also want to learn from Vue and Futify, which through IPyVue and IPyFutify, we built Solara on top of. And we want to kind of take some ideas from Next.js, which is this batteries included framework where you get everything. You get servers, you get routing, you get everything in one package. So, to build large apps in Python, we need to learn from JS, we need to learn from React in particular. But in order to learn from React, we've got to understand what React is. And this is the core idea of React, is that the view, what the user should see in their browser, should be a pure function of state, that is the user's interactions with the UI that you've built, and the stuff that they have done before they came to this particular page, or so, and data. So the state comes from user interactions, the data should be from server. So keeping that idea in mind, we want to bring this to Python. And we want to build on existing tech because one of the big gripes people have with a lot of, especially newer UI frameworks, is you want to have components because you don't want to spend days trying to make a select menu or something. You want the component to already be there. So we want to build on existing technologies like IPy widgets, where we can take their easy extendability, so people can make their own widgets and use those within their applications. And there's already an existing component ecosystem that we can leverage. Additionally, we want to build on Starlette FastAPI for their versatility, and because these are, again, proven technologies that are production ready, they're battle tested, and they're based on standards like WebSockets that we want to make use of. So how do we make it? Well, I'm going to walk you through the composition of the Solara package. We have 3 parts: Solara server, Solara UI, and PyTest IPy widgets. And then some extra goodies stacked on top. And keep in mind that we want to make a complete app framework that comes with the batteries included. So this Next.js idea, if you're familiar with it. Otherwise, I'll tell you where it applies over the course of the talk. The first bit is Solara server. And what Solara server does is it enables IPy widgets to run outside of a notebook, Jupyter Lab kind of interface. So you can take a Python file with some widgets in it, and you can render that directly to the browser. And this means that we can leverage that IPy widgets ecosystem because we can already use, or at least almost all IPy widgets in Solara. The other important thing about Solara server is that it's got one process to which you connect many virtual kernels, so you don't need to start a separate process for each kernel. This means that there's not going to be an import time or process startup time when you connect when your user connects to your site. This also enables us to share data, and importantly, share memory. If you have some sort of data that is immutable, that you need to keep in memory for the applications to run, it can remain in memory, and all of the users can read from that memory. And this is actually a huge gain when comparing to something like Voila, because you have this shared memory that you can make use of. So something like Cosmic Data Stories that used to run on Voila moved over to using Solara, and they saw an 8 times a reduction in costs for running their web app. How do you use it? Solara run myapp.py. It should have some widget or some Solara component that I'm going to elaborate on the next slide that Solara can render for in the browser. And you can also run just notebooks, and it should render all the outputs and put those into an app for you. So next bit was Solara UI, provides the UI components. So this dialog GIF that we have playing here, and buttons and selects and sliders and anything you could want. Hopefully anything you could want. The other important bit from Solara UI that we get is the reactivity system. So we have these reactive variables, solara.useReactive, which means that you can essentially make state in your app. When the user clicks a button or when the user enters something into a text field, you should have a reactive variable hooked up to it, and then you can know what changes happened. So how would you use something like Solara UI? Well, you make components with this decorator here, and you define some button that should have some widget or some prior component in it, and then you can render that to the browser through Solara. The other idea we took from React is that components should be composable. And this means you can build this big UI for your app by putting a bunch of components in it, and everything should work. So you could create something like this myControls component that you put your button in and you put some text input. So then we need to hook it up to state and add reactivity. So we declare a reactive variable inside the component. So you could use this myControls component multiple times in your app, and each one of those would have its own state that's independent of the others. And these reactive variables have a value and have a setter, so you can change the value and you can read the value. And we hook it up to this input text, and now if a user types into that text field in their browser, you see the change. And everything that relies on this variable is going to be automatically re-rendered, and then you can get the fresh data. Finally, you need to get it to the user. So you could use a widget, but you need to declare some page variable And that is what Solara automatically looks for in your Python file and then renders that. So final third piece, PyTest IPy widgets lets you write unit tests for both Solara components and for IPy widgets. And this is important when your applications start reaching scale. You want to make sure that you test them so that nothing breaks for your users. And how you do that easily is you could write unit tests for each component. You could test the internal state of the component, see that it reacts the right way. At least you know the building bricks work. Cool. Here's an example of some tests you could write for a checkbox, where we create an onValue function that should be called whenever a state changes. We create a checkbox, but note, we don't need to hook any front end up to this. We don't need to actually render this checkbox. We can just have it live in the widget side of things, and we can test everything purely in Python through that. So we give this checkbox value true, which means it's checked, and we hook this change function, or this function that we want to be called when something changes, up to that. And then we can change checkbox.widget.vModel, which is the value of that widget, to false, and see that everything works correctly. The onValue function should have been called once. And then you can elaborate on this logic and test all of the functionalities of your component. Some developer experience stuff. So Solara is typed, so you hopefully write fewer bugs when you're making your app. And we've got an auto refresh function, so if you change your app and you save the file, it automatically refreshes all of the sessions that are connected to that server. So you could have a friend of yours looking at the thing, telling you, looking at your app, telling you, oh, I need this to change. You save that change and it should refresh for them. And we also try to keep the state around on these hot reloads. So if the user has already navigated somewhere or entered something into a text field and you save some changes, they shouldn't lose that. Something I also wanted to mention is we're approaching 2.0 by the end of this year, we hope. There should be some more developer experience stuff in there, some improvements to component APIs, and we should make everything a little bit more explicit and less magic, which I hope people appreciate. It's the kind of the Python way. So, recap of this section of my presentation. So, our problem was we wanted to build large web apps in Python, and in pure Python specifically. And I hope I've convinced you that Solara could be the solution. It's efficient, it's reactive, it's composable, it's testable, and it's type safe. So it should give you a good framework for building larger apps. So in conclusion, for the first part, performant and robust batteries include a framework which hopefully works for all of you. If there's not any super pressing questions, I'll do a kind of separate detour. Nothing. Okay. So, a short case study that I've called What Makes Reactivity Systems Difficult. We ran into some issues with some stuff that we wanted to introduce in Solara 2.0 because there was an inconsistent state that you could get. And this is because of the way that our reactivity system works. So we've revamped it a little bit. And I thought there were some interesting insights that you could draw from that. So to know what makes these systems difficult, we want to know what kinds of systems those are. In principle, there are three types. There's push systems, pull systems, and push-then-pull systems. And push systems, you change something in the state, that gets pushed everywhere, the value is updated in everything that depends on it, and everything is rendered that way. Pull systems, you change something, you say that, okay, this has changed, and something pulls in those changes. For example, this could be something running on a timer. Every 10 milliseconds, the page will check if something has changed and then re-render if something has. And push-then-pull systems I'm going to elaborate a little bit on later. So this was one of the reasons I wanted to bring up Solara 2.0. Like I said, we ran into some issues. There's a couple of types of common issues you run into with reactivity systems and reactive programming. It's mutable state, which is quite common in Python as well, because it's very difficult to track state mutations and then tell the application that something in the state has updated. Concurrency and order of execution, if you were re-rendering only a part of your page, but some of the components, for example, expect a different function to be called before they are executed. That might not happen because you're not actually running that function. And cyclic dependencies become a problem. You could end up with infinite re-renders and then the user doesn't get to do anything. So there needs to be some thinking to be done about these reactivity systems. So the issue we ran into was with Solara computed. And computed properties are things that derive from state. So every time a state changes, we should recompute something. So this could be something like, for example, we could compute the initials from this kind of object that holds a first name and a last name. Okay, we make a Solara computed that takes the first letter of each and puts them together somewhere. So now if we were to update this object from Alex Johnson to Sam Smith, you would expect that we would have two different initials computed. But that's actually not the case, because we worked on a push kind of reactivity system. So you would get an inconsistent state. Basically, we would change first, even if we're changing these two things at the same time, one of them would change first, and then that would be pushed everywhere, and then the other change would take place. So you would end up with an inconsistent state. You would get a third set of initials in your thing, and this is not desirable. So we wanted to find a solution to this problem. And again, we went looking in the JavaScript land, and we found a new standard proposal for JavaScript called Signals, and they use a push then pull system. So basically, if something changes in the state, you set the new state, and you flag that reactive variable as dirty. So you tell the application, okay, there's going to be a re-render happening because something has changed. But you don't actually tell the rest of the application what the new value is yet. Then you do all of the other sets that you have. So you change all of the other state values, and then you start re-rendering. And then when you're executing, you get in all the new values. So in our previous example here, instead of changing first name first and then last name, you would still do it in that order, but that change would only propagate once both are changed. And that would actually end up with us in what's called a glitch-free reactive programming system. And this is what we hope to implement in Solara 2.0. So we fixed the issue we found, and everything should work brilliantly. So, conclusion for the second section: you should learn from other communities. We've done a lot of learning from JavaScript, and if there's problems that have been solved by others, maybe they don't work for you directly, but they surely have some insights that are worth taking into account. And on that note, I want to thank you guys for your time and welcome any questions.
So thank you, Izaki, for your talk. Has anyone questions or?
Thank you for the talk. Very, very interesting framework you got. If we, say we already have a bunch of notebooks that are being rendered using Voila and served up to users that way, could we assume that we could just deploy Solara, migrate everything over, and everything would work for the notebook case, or?
I think there might be some very minor changes you need to do. So for example, this page variable needs to be there for Solara to know what to render. But in principle, that should be as simple as declaring whatever you want to be output, page equals that. And then in the notebook, if you want to use it in Jupyter Lab or Notebook, you just say page, and then it renders it. But in Solara, then it would grab that and put it into the web app. So it takes maybe some changes, but it shouldn't be anything major. Next question?
Yes. Thank you, Izaki, for the talk. And I'm not sure how good a question this is, but if you look at the current state of applications generally where there's Python used in combination with React, for example, Django and React.
Yeah.
And now, do you think that the use case for your Solara is something which it could replace this kind of a scenario? And if so, what is the need to replace this kind of a hybrid?
Yeah, so I mean, the need for that replacement is usually devs excel at one or the other. They do front end or they do back end, and maybe in different languages. So maybe you need, for example, for a company, you would need two different teams, a front end team and a back end team. And then everything gets clunky. You need to have meetings, and you need to make sure that everything stays in sync. So it's kind of optimal that one person or one team could do the whole job. And there's actually something we're already kind of seeing in the JavaScript land, where Next.js and these kinds of frameworks provide everything and let you do backend and front end both in JavaScript or TypeScript. So I think there we fit in quite well because we are already seeing this transition to kind of one language, front end, back end, do everything in it. And so maybe we could be the Python end of that, as opposed to moving everything to be in JavaScript.
Hello, thank you for the talk. I have a question about the other framework that we can use for deploying like web apps. I have some experience with Streamlit, so how do you compare your solution Solara with the other framework? Thank you.
Yeah, I mean, Streamlit is hugely popular, and it's a brilliant tool for, especially for light, small apps where you need to do show something to the user. They need to maybe I don't know, look around on a map or select something from a menu or something like this. And we really want to aim for that kind of proper app experience with Solara. So you don't need to have this kind of small snippet. Well, of course, in Streamlit, you can also build larger things where you run into performance issues because I don't think partial re-renders are in Streamlit yet. They've been planning it for quite a while, as I understand it. But in Solara, it's possible to change something and it only re-renders the parts of the page that need to be re-rendered. Whereas in Streamlit, it would execute everything from the top. So you get some performance gain and so on and so forth. So hopefully, for larger apps, I think Solara is a good choice. And for smaller applets, Streamlit is definitely, I mean, it's kind of the king in the ecosystem at the moment. Yeah.
So 2 questions for the price of one. Have you, are you guys, I'm a big fan, by the way. Are you guys working on execution in the browser with in-browser kernels, that sort of things? So that's the first question. And the other one, and then I shut up, is have you looked into collaborative experience like with CRDTs and that sort of workflows where multiple clients could be co-editing a dashboard or an app?
Okay. Well, this goes kind of into what I mentioned. I work on the other project from us, PyCafe. And hopefully I'll give a lightning talk on it at some point. But that runs completely in the browser on top of Pyodide. You can render Solara apps, you can render Streamlit apps. Not in Solara, but in this other project. For collaborative editing, it's on the state of thought. We have thought that it would be a nice feature to have, but we haven't got into implementation yet.
Hi, can you hear me?
Yep.
Thanks for a great talk. One question, you're comparing yourself to the React and the Next.js world. It has huge resources and a really large community. How do you see yourself depending on IPy widgets and that infrastructure compared to the other one? Like if you're a big company wanting to build something.
Right. Yeah, I mean, a part of what makes React so successful is that they have a lot of community projects, Material UI or whatever. And I hope that as Solara grows, we can also have some sort of community components and projects that you could use into or pull into Solara. Right now, mostly we use Solara through, like I said, IPyFutify, but we've already got some solutions for running other front-end frameworks on it. For example, anti-design. We already have a kind of IPy widgets anti-design port working that you can then again use in Solara directly. Well, hopefully we can be dependable, and hopefully we'll grow as it goes. Otherwise, I mean, we'll still strive to provide quality applications and so on. Hope that answers your question.
Anyone else? Okay, so thank you, Isaki, for your talk.
Thanks.
Can we have another round of applause?